Hello, and thank you for viewing this presentation. I'm Nick Clark, Farm Advisor with the University of California Cooperative Extension, and I'll be presenting partial results from a research project which characterized the physical and chemical composition of manure found on California dairies. In a project funded by the California Dairy Research Foundation, we sampled manure at dairies in California to learn more about the physical and chemical components of the manure. The goal was to characterize manure from various treatment technologies and manure handling points on dairy facilities. The samples we collected were analyzed in-house for solids content and at a commercial lab for plant nutrient content and other chemical properties. In August of 2021, a manure lagoon in the South San Joaquin Valley was drained and the settled sludge was excavated. 8 composite samples were collected across the excavated face over 9 days. The first analyses of moisture and solids content revealed that approximately 75% of the material was water and 26% were solids, where just under half of those solids were considered volatile or organic compounds. Although the moisture content suggests there may be challenges with directly land applying this material in a uniform manner, the chemical composition indicates it would make an acceptable fertilizer material or compost feedstock. The macronutrient, or nitrogen, phosphorus, and potassium content of the sampled manure as received by the lab was 0.7, 0.7, and 0.2% respectively. In other words, it had an NPK fertilizer value equivalent to 0.7, 0.7, 0.2. Total carbon and nitrogen averaged 6.3 and 0.7% respectively. The carbon and nitrogen ratio was 9.0, which suggests the organic nitrogen in this material was likely to be highly mineralizable or readily converted to plant-available nitrogen. Most of the nitrogen in the manure was organic. Looking at the makeup of total nitrogen in this manure, we observed that organic, ammonium, and nitrate nitrogen comprised 85, 14.6, and 0.8% of the total nitrogen respectively. We also analyzed the manure sulfur content as well as the base cations calcium, sodium, and magnesium. Calcium content at approximately 1% of the manure as received by the lab had the highest concentration by orders of magnitude. The low sodium content is a desirable characteristic for fertilizer products or compost feedstock. Take these messages away from this presentation. This material had a high moisture content and may pose challenges with direct land application. It may be more suitable for further drying or use as a compost feedstock. The low sodium content and relatively high rate of calcium with notable sulfur means this material is not likely to contribute to irrigation water infiltration problems when land applied. The carbon to nitrogen ratio of 9.0 means this product is likely to undergo net mineralization of the organic nitrogen, making more of the total nitrogen immediately plant available. Finally, abundant phosphorus and organic nitrogen can be a significant source of plant macronutrients found in this material when applied at moderate rates to cropland. Thank you very much for listening. That concludes this presentation, and I look forward to hearing your questions during the live Q&A session.